denoted by this function z equals f of s1. And you are specified by a region of integration. For example, in this particular case, our region of integration is relatively simple. Therefore, we want to estimate the area. Okay, so what we want to do is we want to estimate the surface, the volume under the surface, z equals f of xn1, but over the region of integration. That means our region R. So your region of integration in this case is very simple. It is just a rectangular. And its x will start from A to B. Its y will start from C to D. And the inner radius will be R1. And the change of the angle will just be delta C. Okay? So that means the area of the polar center will be represented by delta theta over 2 pi times the area of the entire ring. Okay, what is the ring? And this equation will be simplified to delta theta. Okay, times R2 minus R1 times R2 plus R1 over 2. Okay, this is simply because this formula, say a squared minus b squared will be equal to a minus 1 times a plus 1, a plus b squared. Okay, so this will give you delta theta times the change of the radius, which will be delta R. Okay, and what will be the R2 plus R2 plus R1 over 2? This part will just be the delta R, the change of radius. Then what will be the R1 plus R2 over 2? It will just be the mean radius. So if we choose to use the simple R to represent the mean radius, then the equation will be simplified to R times delta R or delta theta times the other delta theta. And what will be the area of this small polar center? It will be the mean radius times the change of the theta times the change of radius. Coordinate into polar coordinate. Then you have several things to do. The first thing is you have to change your dA into R times the R dθ. And also don't forget your integral. Originally may be determined by the x and y position. But when you are doing the conversion, the coordinate conversion from rectangular to polar, okay, this is from rectangular to polar. You need to substitute x as r times cosine of theta. Y should be substituted as r times cosine of theta. So therefore, in the original integral, your x should be changed to r times cosine of theta, and your y should be changed to r times sine of theta. So in other words, to do the double integral in polar coordinate, you just have two things to do. Firstly, always remember to change your dA to be r times the r dθ. Anyway, this is the first thing. And the second step will be, remember to change your x and y according to this conversion formula. Okay, so today we are going to continue to talk about the moment of inertia. Extend a little because we want to talk about the so-called radius of gyration. And what is the radius of gyration? The gyration is with n If you want to find the radius of gyration, we just take the square root on both sides of the equation. Okay? So the R double hat usually R times the density function dA. Okay, this is what we know, variance. Okay, for this function, and the function is defined to be z equals 1 minus a squared plus 1. So that means this is just the region we want to find. Then that means on the xy plane, remember this is the x-axis, and this is the y-axis. And if you do the y integral as the second integral, now we already know at least how to do the triple with respect to some kind of pivot. And what will be the pivot? Pivot is what we call the G. 也就是向上摆的基点，就是一举旋转旋转的基点区块。Now let's see what will be the moment of mass in three-dimensional space. Okay, so here, if you want to find the center of mass in three-dimensional space, that means again we want to find out the weighting x value. What will be the weighting? The weighting will be the mass. Okay? So here this is equivalent to x weighted by the submass. Okay? Take the x position times the mass. It will be equivalent to each. If you take the sum, it will be what we call the moment of mass, or the first moment of mass, about the y-z.
Everyone, today our EMI presentation, our tremendous switches and yoga and equate. Our question is to use for shorthand to find the volume of the solid under the plane. Z equals 4x and solve the circle x squared plus y squared equals 16 in the xy plane. And we turn the rectangle coordinate to the polar coordinate, where x is equal r cosine theta, y equal r sin theta, and dy dx equal r dr d theta. And we generate this diagram. And how can we solve this question? First, we need to convert rectangular coordinates into polar coordinates. So we substitute 4x with 4r cosine theta, and we replace dy dx by r dr d theta. And next, we need to find a bound of r and theta. In terms of r, we find a radius is 4 from this equation. And in terms of theta, from this diagram we can find the limit of integration is from negative 90 degree to positive 90 degree. And finally, after evaluate double integral, we can get an answer is 512 over 3. And thanks for your listening.
Sometimes it's very important to use visual aid to find out the limits. Okay, what they do is very good because they find out the computer grading tools to find out the exact region and to determine the region of integration. Okay, so what is green theory? it says that if you are given a force field, a two-dimensional force field, okay, so maybe it is defined to be the S force in the I direction and the Y force in the J direction, and there's no K component. That means there's no Z force. Then for this kind of force field, of course we can try to calculate the force when it is moving some object along a given path. Then the force will do some kind of work, and the work of course can be denoted by the line integral over the integration path of the force field dot the displacement vector dr, and it is equivalent to its differential form. And in the differential form, we say that the total work will be equal to the work done by the S force. Therefore, it will be the S component of the force times the displacement in the S direction. This is your work done by the S force. And also, it also contains some kind of component that is done by the Y force in the Y direction. So you notice that here the capital N is the Y force times the Y. That means the displacement in the Y direction. Therefore, their summation will be what we call the total work by the force field on the integration path. Say C. Okay, so usually it takes some effort to calculate the line integral to find the work by the force field. However, if you found that your integration path C is a closed loop. So what is a closed loop? That means you are moving in some kind of circular behavior such that your initial point is actually equivalent to your terminal point. This is what we call the closed loop path. Okay, so when your integration path C is a closed loop path, then the Green series says that the work done by the force actually will be equal to a double integral over the integration region that is bounded within the closed path loop. So that it will be the R. So that means it will be equal to some kind of double integral over the integration region R that is within the closed loop, dA. So this is a double integral. Then what will be the integrand for the double integral? It will be the S partial derivative of the Y force component subtracted by the Y partial derivative of the S force component. Therefore, what will be your integrand in the double integral? It will be equal to the capital N ds minus the capital M dy. This is what we need to know about the Green theory. Then we can proceed to today's lecture.
Hello everyone, I'm Li Mingxuan. I'm here to present a calculus problem. The question is to calculate the integral of x times ln x. So the first thing we need to know is this is a perfect situation for integration by parts. We know the formula. The integral of u dv is equal to u times v minus the integral of v du. This formula helps us break down a complicated integral into something easier to handle. The trick is to assign them to u and dv in a clearer way. We have x and ln x multiplied it together. We want to choose u as the part that will simplify when we differentiate it, and we want the v to be the part that's easy to integrate. So let's set u equals to ln x because the derivative of ln x is much simpler. It's just 1 over x. And dv equals to x dx because the integral of x is quite easy. It's s squared over 2. Now we can apply the integration by part formula to rewrite our question as s squared over 2 times ln x minus the integral of s squared over 2 times 1 over x. Then we simplify the integrand into 1 over 2 times the integral of x. Now let's calculate the integral of x and combine everything back together. Then we can get the final answer is 1 over 2 x squared times ln x minus 1 over 4 x squared. And don't forget to plus a constant c. And that's it. Thank you very much for listening. Hope this video will help you, and don't forget to subscribe. See you in the next video.